we are looking at section 3.3. We're just talking about properties here, and specifically expanding and condensing logarithms primarily. So the product property of logarithms tell us that if we have log of any base and we have two things multiplied together, we can separate those two things with addition. Just like you can go from two things multiplied to addition, you could go from addition to multiplication, right? So this would be the condensed version, this would be the expanded version. Do we understand that? Yeah. So the quotient property is the division, so m divided by n. So log base b of m, and with division, it expands with subtraction. So the expanded form condenses with division. Questions on that? And then the power property tells us that if we have log base b of m to some power, you can take that power down in front and you'd have a power or a number times log base b of m. And that works for any kind of base. All right. So let's just practice some of these. It says to expand. So we're taking some things that are multiplied, right? And if they're multiplied, we're going to expand them with addition. So we have three things there that are multiplied. Do you agree? So we can expand them and we would have log of 8 plus log of x plus log of y to the fourth power. The thing is 8 can have a smaller base, correct? What to some power gives us 8? So log base 2, or log of 2 to the third power, right? So you need your numbers with the smallest base you can get them to be. Plus log of x plus log of y to the fourth. Once you have that, this power property tells us we need to bring these exponents down in front. So here, this would be equivalent to 3 log of 2 plus log of x plus this, we bring the 4 down and we would have 4 log of y. That would be the expanded form. Questions? So what's important here is that a square root can be written with an exponent. Do you agree? This is the same thing as saying x squared plus 5 to the 1/2, right? Over x. So we have two things that are divided. Do you agree? And so to expand division, we subtract, right? So we start with the numerator. That'd be natural log of x squared plus 5 to the 1/2 minus natural log of x. Now some people want to say, well, that's natural log of x squared plus the natural log of 5. And that's not true. Remember, we can only expand these if it's multiplied inside here, right? So the only thing we can do is bring this 1/2 down in front, and we'd have 1/2 natural log of x squared plus 5. We can't simplify that any further. minus natural log of x. That's all you can do with that. And then with condensing, we're basically just doing the opposite, right? So let's look at b first, because this is the simplest one. This is subtracted, which means what would we do to condense it into one logarithm? And that's all we could do on that one. We can't do anything else. There's no exponents. There's nothing like that, right? All right, let's go back to a then. This is subtraction, so we know we're going to divide, but what about this 2? What do we have to do with it? We have to pull it up. Yes? So we still have natural log of x to the 5th minus natural log xy has to be in parentheses because all of that is squared. Yes? And now we can condense it into one logarithm, x to the 5th over. This is the same thing as saying x squared y squared, isn't it? Remember that power goes to both things in the parentheses. And then can this be simplified further? Yes, because you have x to the 5th over x squared, right? And when you have x to the 5th over x squared, we can simplify that and we would take the x up, right? Because the larger exponent's in the numerator. And you would do 5 minus 2. Do we agree with that? And that would be x cubed over y squared. That's your properties of exponents, right? That you've been doing since Algebra 1. Everybody remember that? Let's look at C. What would we have to do here? We have to bring the 3 up here, yes? And we have to bring the 2 up. Everybody agree? So we have natural log of x cubed y all to the 3rd power plus natural log of y z squared all squared. Everybody good with that? So this right here, if we simplify that before we condense it, you would have to do x cubed cubed, wouldn't you? Which is x to the 9th. And we would also still have y, yes, plus natural log of y squared and z to the 4th power, correct? Now, when we condense these into one logarithm, we have natural log of x to the 9th y cubed times y squared z to the 4th. Can I simplify that further? Yes. Right here, the y's can be multiplied, can't they? And so we have natural log of x to the 9th, y to the 5th. That's right, because you add those exponents. Z to the 4th. Questions? Okay, change of base formula. If we have log base b of x, we can change this to a common logarithm or a natural logarithm. So common logarithms, remember, have base 10 by doing log of x divided by log of b. So remember, the base goes to the bottom of the fraction, yes? And the reason this would come in handy is because in a lot of instances, you can't use a graphing calculator. If you can use a graphing calculator, we have a way to put in any base. If you go alpha y equals, you can see there, you can use that log base, and you can put in any base, right? Log base 2 of 8, for instance, is 3. But in college algebra, they don't let you use graphing calculators, correct? At the college. So you wouldn't be able to do that, right? But one of those regular scientific calculators does have log on it, and that's base 10. And so you could do log of 8 divided by log of 2 on even one of those most basic scientific calculators, and it gives you the same answer. That's where this change of base formula comes in handy. Okay? You can also, I said, use it with natural log. So if you have log base b of x, you could have used natural log of x over natural log of b. Same thing. It's just the different button. Most of those scientific calculators have both available. Okay, example 3, it says evaluate the logarithm by changing the base. So it tells us we have to change our base, right? So if you're using common logarithms, it would be log of 13 over log of 3. Or if you're using natural logarithms, natural log of 13 over natural log of 3. And if we plug that into our calculator, log of 13 divided by log of 3, or we do natural log of 13 divided by natural log of 3, it gives us the same answer, doesn't it? So 2.334717, whatever, yes? And we go to how many decimal places? So 2.334 or 2.335. If it tells you to round, you have to have that one, yes? Because that 7 would make the 4 go up. Everybody agree? All right, looking at this one, log of 10 over log of 6. Well, I know that log of 10 is just 1, right? Log base 10 of 10 would just be 1. Do you agree with that? So 1 over log of 6. Or you could have used the natural log of 10 over natural log of 6. Either way, we get approximately 1.28509, and it just kept going. So 3 decimal places would be 1.285. Here, this would be log of 2 over log of 1/2. But this is divided, isn't it? Yeah? And when something is divided, what do we do with it? Expand it with, so this would be log of 1 minus log of 2. Do we agree with that? Well, that would give us log of 2 over, what is log of 1? Anytime you have a 1 here, what was that property? 0. 10 to what power gives you 1? 10 to the 0 power gives you 1, yes? So 0 minus log of 2. Well, then I have log of 2 over negative log of 2. What does that equal? Yeah. Because log of 2's would cancel, and you'd just be left with -1, yes? 1 divided by -1. Questions? Okay. Here it says f of x equals log base b of x with b greater than 1. So we've already graphed these, haven't we? With a base of 10. and a base of E. Yes? The key is you're going to have a vertical asymptote unless it has been translated. Your vertical asymptote is going to be at x equals 0. Yes? And you are going to have a point at 1, 0. Do you agree with that? The other point, remember when we had base 10 was 10, 1? Do you agree? So with any base, it's going to be whatever that base is and 1. Do we agree with that? So no matter what the base is, you're going to have a point at whatever the base is up 1. So if our base was 2, we'd have a point at 2, 1. Yes? Questions on that? Okay. Our domain of every logarithmic function that hasn't been translated is going to be from 0 to infinity. And our range is going to be, it is continuous and increasing on its domain. There is no symmetry. It is not bounded. There's not going to be extrema. You're not going to have a horizontal asymptote, but we will have a vertical asymptote. And our end behavior is going to be the limit as x approaches, how far left does it go? So the limit as x approaches 0 of the function, and what's going to happen? It's going to negative infinity, isn't it? As x approaches 0, the function's going down. And the other end would be as x is approaching infinity, correct? Of f of x, and what is the function doing? It's going to go to infinity. Okay, let's translate those. Actually, we're not going to because this isn't really translated, is it? Right? Okay. And it's not really, this wouldn't be my, yeah. Okay. So looking at this, here you can do this one of two ways. One of the ways is we should know where our initial point is. We should know 2 points, right? Pretty easily. So automatically looking at this, I know I have a point at 1, 0. And I have a point at 5, 1. And so looking at that, I could do that really easily. The other way, if you can't do that really easily, is to change it to an exponential equation. So my exponential equation would be 5 to the y power equals x. Yes? I have x and y. That means I'm going to be plugging in for y to get x. Do you agree? Anything to the 0 power is, there's my point, 1, 0, right? Anything to the first power is itself, right? Y to the first would be, there's the other one, yes? And if I plugged in -1 for y, the negative moves it to the denominator, and it would be 1/5, yes? So you could see here, you have a point at 1, 0, and a point at 5, 1, and 1/5 -1. And so whether you did it by knowing these points by just looking, or you did it this way, that either way is fine, you need to label that 0.10 and that 0.51. Does that make sense to you? On this one, we automatically know we're going to have a point at 10, right? Because it's not translated left or right, is it? Or up or down, meaning it doesn't have parentheses or it doesn't have something added or subtracted outside. Do we agree? The only other point we know is 1/2 one, right? And so because of that, we might need another point, right? In which case, you could change this to 1/2 to the y power equals x, right? Change it to exponential form. We know if we plug in 0, anything the 0 power is 1. If we plug in 1, 1/2 to the first power is. If we plug in -1, that's 1/2 to the -1, right? To get rid of the negative, we flip it. And so we would get 2, yes? So that means when I go right 2, I'm down at 1, yes? And that's probably not a very good point there, considering how far up that was. And so this is going to continue to go down and to the right, and this is going to continue to go up, right? And so you can see what's happened here. It's reflected across that x-axis, right? Because of this 1/2, which results in 2 to the -y equals x, yes? Is that fair? Okay. So making sure we label the point 10 and at least label 1/2 1. Okay, last example here says the data below represents the price and quantity demand for a personal computer. Use a graphing utility to draw a scatter plot. So you're going to need a calculator and you need to be doing this. So if you don't have one, you need to get one quickly. So to put this in a scatter plot, we need to go to Stat and Edit. So right there is your Stat, and we are going to Edit. And you should have L1 and L2, yes? And so this would be your list 1, this is going to be your list 2. So you just enter that data. Once you have your data in and you've checked to make sure everything matches up, you have the correct points, then you have to do second stat plot, and we need the plot on. So here you would do second stat plot, which is your y equals. And we need, see how I have list 1 and list 2 in that first stat plot? I need this on. So if yours is off, you have to go to on and hit enter. Yes? Making sure that you have L1 and L2 and you have the scatter plot selected, not any of the rest of them, right? Yes? Okay, so then to graph it, we do zoom, stat, so zoom, stat is on mine, it's number 9. And you can see it graphed, yes? Now it says fit a logarithmic function to the data. So you go stat over to calculate. So right here, stat over to calculate. And what are we calculating? A logarithmic function, right? So this is linear, this is quadratic, cubic, quartic, linear, ln, and, ooh, oh, darn it. So ln is the only logarithmic one we have, right? And so that would be a natural logarithm right there. And so if we hit enter, some of them, you're not going to come up with this. Mine comes up with this. So I've got this, and actually you could store this if you want to. Wherever you can select where to store it at. I'm just going to calculate it. And so it tells you this is y equals a plus b times ln x, right? And it gives you an a and a b, correct? So y equals, and we're going to put 3 decimal places in there. A is 569.754. And it tells us it's plus b, which actually happens to be negative, so it's not going to be plus, it's going to be minus, right? Because plus a negative. 53.907, and it tells us that we have to have natural log of x. So right there it tells us the form, y equals a plus b ln x, and it gives us the a and the b. We substitute those in. So there's our logarithmic function. So we went to ln regression. Now it says use the function above to find the number of personal computers that would be demanded if the price was $1,500, right? If you go to y equals, oh, I need to clear it out. Go to y equals. And then you go to vars. So right here's your vars. And you go to 5, which is statistics. And you go over to EQ. That regression equation is what we want there, right? Yes? So EQ and hit enter. That regression equation is now in your y equals, yes? If you hit graph, it graphs it for you, yes? Remember doing lines of fit? Where you had to draw a scatter plot, select 2 points, write an equation line, yes? Y equals mx plus b. You can do that with quadratic, you can do it with cubic functions, you can do it with logarithmic functions, yes? So now we have that in there, yes? So we put it in there and then we went to graph. And now that it's in there, I can go to my table and plug in whatever value I wanted, 1500, and it gives me the y value, doesn't it? So it wanted 1500. So once we get to our table, we can find the value, any value. Yes? This is my x, and it gives me my y. Yeah? And so this tells me that my y is approximately 175.52. Well, in this, what is that representing? It says the data below represents the price and the quantity demand for a personal computer, yes? So that tells me there is about a demand for about 176 computers at a price of 1500, yes? If you plugged 1500 in for x in this equation, you're going to get close to that, but are you going to get the exact amount? Probably not. Does that make sense? Questions? So I wrote the steps there, and the reason I wrote the steps there is because you probably need to practice those steps in order to remember those steps, yes? Okay. Questions? All right.